You just like
in all caps,
and then you raise
Okay.
it when you.
So, lesson 24.3, log equations. Thanks for reminding me. We have to check our answers, so you can pause the video and read this paragraph for yourself. We have to check our answers if I have log base 7 of x equals 20, and my answer is negative 2.5. That answer does not work because my base and my argument have to be positive. So that answer wouldn't work. Let's look at exponentials, and I have this. Can I plug in a 0 for x?
Yeah.
Could I plug in negatives?
Yeah.
Can I plug in any positives?
Yeah.
There are no restrictions on exponentials. You can plug in any value you want. So those don't necessarily have to be checked, although checking your answers is always a good idea. But for logs, they have to be checked. We're going to skip over this example that's done, and we're going to go to ours. Like always, you might want to put your notes on a separate piece of paper because there's not a lot of space. What do we think about beginning this problem by adding 1? Good idea, bad idea?
Illegal.
Illegal. That's a bad idea. You do want to get rid of adding and subtracting, but this isn't just a plain old -1. It's inside of a log, so it's not really just a -1. All I have on the left is the log, so I'm ready to do inverses. What's the inverse of a log of base 3? An exponent of base 3. So I'm going to make the base 3. I'm going to make the base 3. The exponent base 3 and the log of base 3 are inverse operations. They undo each other. You could use the word cancel. And then you get a calculator and type 3 to the 5th. Hello.
5 to the 3.
We are free.
Did we already get it and start looking at it?
Yeah, I guess.
Is it 244?
243.
243. And then, of course, now is a good time to add 1. So my final answer, as long as it works, is 244. So please take a minute, plug in 244. You have to use that special log button, the log base button. So math, log base 3. I'm going to type it just like it looks, 244 minus 1. Of course, you could type 243, and it does work. You can. Do you think you can do B and C on your own? Well, I think you can at least start it on your own. Go ahead and get started.
We are on a roll.
You'll know if it's right by plugging it back in. Keep going if you're working. If you need help, think about getting rid of add, subtract, multiply, which we don't have anything that's outside of the log. So we're ready to do inverse of log base 2, which is an exponent that has a base of 2. What?
So I did not do
Oh. Did you find what you did wrong? What was your first step?
I got 2 to the 3rd, and
Uh-huh.
then so I got 2. Or God made the base 2, so then I got 2 to the 3rd. So then I got 2x minus 3 equals 8,
Yeah, that's what I have.
and then I just added.
Oh, when you plugged it in, it wasn't working.
Yeah,
So you added 3
yeah,
divided by 2, you got 5.5.
yeah, and then I plugged it in. And I did it.
Okay, let me
Plugged
see.
it in right.
I would say leave it as a fraction unless it's exact, which 5.5 is exact. Yeah, so you plug in 5.5, but you have minus 1. You just forgot your minus, over here. Yeah, it should be 2 times 5.5 minus 3.
Oh, okay. Got it.
Whatever, I get it.
Raise your hand if you've checked 2 already, or B, I should say. Great.
I got that. I plugged it in, and I also didn't get 3. I got
Let me see.
3, 2, 1.
So you have log base 2 of 2 times 5.5 minus 3. I don't see, I saw somebody else have that when they did the prices. It should have worked out.
How else would I do it to get?
Try this, clear that, type just the argument part, 2 times 5.5 minus 3. 2 times 5.5 minus 3. Enter. Now hit log base 2. And then you can type that, or you can also just hit second answer.
It's still wrong.
Oh, well, you put the parentheses in the wrong part there. It's 2 times 5.5 minus.
Oh, that was just the one I messed
Yeah.
up before.
For
See?
Yes.
I plugged this back in, I plugged it back in.
Yeah, because it's rounded.
Yeah, okay, yeah,
Yep.
I thought
So
it
it's, oh my god.
All right, letter C. Don't forget to get rid of the times 4. That's completely outside, not really in the log. So divide by 4 because it's being multiplied. Remember, ln is a log of base e. So the inverse of log base e is an exponent that has a base of e. So I would have 3x equals e to the second.
Oh.
I get that decimal and divide it by 3. It doesn't say what's round to, so let's go hundredths. When I type in my rounded answer, I will not get exactly 8 because my answer is rounded. I will get close to 8, and that's okay. Any questions on A, B, or C? Yep.
Okay, wait, so why isn't the base like the same? Like, so in the other ones, how you had to make the base the
Yep.
same? What?
These both have a base of E
Oh,
because ln is log base E. Yeah.
okay.
Other questions on A, B, C? Okay, we're going to skip over the one that's done in your book for you. Actually, no, let's take a look at it. It's really a very quick question. If you look up here, log base 3 on both sides, it would make sense, hopefully, if these things are equal, they all both have a log of base 3, that this would equal this. Does that make sense? You can just see it. Even if you didn't know what logs were, maybe it would still kind of make sense. So then I can set 2x plus 3 equal to x plus 4. Solve for x. Don't forget to check your work. This will happen sometime, so it's not happening in A, but we can kind of get to it in B. Let's try A just to make sure we're good on that one. No different than the last 3 you did. This is log of base 6. I'm ready for exponent with the base of 6. Six to the first is 6. Take your time, finish A, check it. Do B, check it.
They gave us no space for A.
Using the space in example B, do A.
I'm just using the side thing, but they gave us nothing this time.
Y'all,
It
the
just
book
keeps getting worse.
guys, I'm actually sitting there watching like a video right now. You just think that's.
I was thinking about that. Like, what if my sister like had to watch this video and she's just like, "Oh my goodness."
Are you just like that? We're just saying hi to the people like generation of people watching.
Right.
Yeah, it could be like 20, like
Whoa.
Imagine.
Where are you going with this, Allie?
a long time.
Whoa. Well, I may not keep these forever, but
I really like the
Why
fact
not?
that you're because they're super helpful.
if we get a new book, I'm not doing it for the new book. I'm just gonna say, this lesson is like this lesson. At least you'll learn it, and then.
Yeah.
Well,
Might as
you'll
well
get
get
to
a new
hear our
book.
lovely voices.
If we do. I would
Oh my.
say that
And if she's here that day, then she wouldn't be. Anyway, B,
no, but she won't be with
log base 5, log base 5. So these have to be equal. Pretty easy algebra there. 4x minus 2 equal. So what happens if you go too fast and you make a mistake? So let's make sure don't make a mistake. 2, I believe. I should check 2 on both sides. There is an x on both sides, so I should plug 2 in, make sure everything works. What do you guys think we should do for C?
Cry. Subtract 1. Add
Subtract
1.
1 or one of the things that are there?
One. I think we add the negative ln.
Yeah.
Or that.
Let's add this to both sides, essentially just moving it over. That's a good thought. It's probably the easiest way to go about this problem, although it's not the only. Probably the way I would do it. We now have ln's on both sides. We know ln is base of e. They both have the same base, so the argument must have to match. Also, X is 4. We have to check our answer. It's not like, oh, it's just a good idea. You have to for logs because not every answer works. You can start from the very beginning. I'm just going to type ln 10. Close that parentheses, minus ln 4 times 4 minus 6. It works. Questions, comments? Do we need more time before we move on to the 3 at the bottom? Okay, let's look at the example that's done first so we kind of have an idea of what's coming up. So look at the board if you would. Here's the next problem. Jillian had a good idea for the last one, which was move one of the logs over. Do you see why that's not going to work quite as well in this problem? Because I'm going to have log base 2 of x. If I move that over, it'll be negative log base 2 of x plus 2 equals 3. And I can do 2 here as a base of an exponent. That works out great on that side. But here, it's not going to work out well. And I can't just put a, oops, I meant to put a plus 3. And I can't just put a 2 here and assume that that works out mathematically. So there's not a good way to move it over and attempt it that way. So here's what they did. They said, you guys have learned what to do if you're adding 2 different logs of the same base. Remember, if you add logs, that could be written as one single log with multiplication. Yes, it's not, no complaining. 2 logs with addition is 1 log with multiplication. Then I can get rid of that with your base, your inverse. And then from there, it's just basic algebra. Let's take a look at the first one. Maybe rewrite this if there's not space. Do we want to move this second log over?
No.
No, not if there's a number there. We don't have another good way to do it except for what they just said. If I have 2 logs, How do I combine two logs into a single log if there is subtraction,
Dividing.
division? Does it matter which goes on the top? Yes. The first one listed goes on top. The one that follows the minus goes on the bottom. Now, I know some of you think this is going to be difficult, but so far we've done nothing new. And our next step is not new either, because all we have is a log of base 4. We know the inverse is an exponent with a base of 4. Do you know what you get after that? Yep, x plus 6 over x. What's 4 to the second? 16. If it helps, you could think about this as being over 1 and cross multiply. X plus 6 equals 16x. It's the same idea as if you didn't cross multiply and you noticed, hey, this is being divided by x. So I'm going to multiply by x so that it's not in the denominator. It's exactly the same concept.
Oh.
Oops, I shouldn't circle that because it can be simplified. Divide by 3, 2/5. So it takes a little bit more time. You guys know how to combine logs. You know how to do inverses. You know how to solve for x. So this is not difficult. Plug 2/5 back in. Check in and see if it's correct.
Is it math?
Do the fraction so that you know how to do a fraction for a quiz. Don't change it and make it easier because then on a quiz I can't help you. Just put parentheses 2 divided by 5 parentheses. I got it to work. Let me know if you need some help.
Oh.
Yeah, if you got a different button that works. Just to divide by b. That might work for you. Might put it. Try.
No, that's why you have to tell me. You make a mistake, you try to go back, and you're like trying to it deletes the next thing afterwards.
I don't understand.
Makes you mind.
I did it.
Good.
2.
Got a handful of people that got it.
This is great.
Oh, I'm so proud of this class for hashtag slang.
Well, you do that with
Wait.
it's like.
Typing that in, I did not make out.
No, like the thing, like the crossing thing, I thought you just like multiply straight across.
Cross, multiply, and divide.
No,
Cross.
cross. You multiply across. So think, okay. If I have 2/4 equals x over 20. If I multiply across, I'd have 2x equals 4 times 20. That's not going to work, but if I multiply across, I get 4x equals 2 times 20 is 40.
Oh my goodness, I just simplify that one
I just
too.
did 20 times.
So it'd be 1/4 over x.
That's what you're doing. 20 times 2 divided by 4. It's the same thing. All right, anybody need me to look at their calculator for A? All right, for B, is it a good idea to move this log over?
Yeah,
No.
Not if there's a number there. Can I combine this log and this log? How do I combine it with what? Multiplying. So ln 2x plus 2 times 5. Go ahead, complete B and C. You don't need to look up because you can check your own work by plugging in your answer.
I'm not gonna look up.
we round to the hundreds. Oh, that one.
You say it like you're alive and you're
There is.
It's second and it's on the divide, but I think it's so funny that we've been doing this evening for like ever and James.
No, I'm not gonna lie. I don't think this is, oh, it's right.
Check it yourself.
Well, I just like looked up real, I did not think I was doing it.
You said you weren't gonna look up.
I know.
Miss Eller, it's broken. I'm not allowed to have negatives.
That is not true. The base can't be negative. The argument can't be negative. That doesn't mean X can't be negative. Maybe it's not. It should be. Look where I'm plugging in X. I'm plugging in X right here. When I take 2 times that small amount and add it to 2, I still believe that's going to be positive. You're combining 2 logs into 1 log with multiplication. No, multiplication.
These two are added, so you can for them.
Yeah.
Oh, okay, yeah, I know.
Remember this? I don't have to look it up. Okay.
Oh, wait, hold on. Wait, so it's one. Oh, okay. Yeah. Like,
Go, Allie, go.
You told me you had it, but I don't think you do. Right here.
I'm confused what the
Nope.
number is for that one. What's that?
I'm confused by Steve where's gonna add square.
B.
No, impossible.
Take M times N. Whatever you have for your arches.
Oh, wait, that's.
Blade bugs,
Oh, sorry.
quadratic.
Oh, okay,
I don't got cash on me right now. I don't got a gift card.
Imagine if we actually.
And then it starts changing.
I think I just like.
We're too loud.
It's so important.
Any questions on B?
No.
Raise your hand if you checked the answer for B.
Just got
I
the.
found it.
Oh, I checked it.
Yeah, I keep getting an error.
Oh, I didn't get it.
I didn't get an error. You have to type.
I don't know if this is a good question to ask.
You might have to put it in parentheses, so you can't really use that. Probably, yeah. So you probably use that button down there. So you'll probably have to like put it in parentheses if you're gonna use that button.
Oh, I just let Penn figure that out.
So yeah, I put 2 parentheses, then I use the negative button instead of that, or the minus button.
I'm your good dad. My dad would be like.
Where's the negative?
I don't know how to solve this.
Where's the negative?
Okay, your 2 didn't go in your log. That 2 didn't go in there.
I'm stuck on it.
So
I'm C.
She's smarter.
I'm C.
No, guys, I'm still on B.
I like.
Oh, that is 0.261.
It came in.
I should have gotten that.
You should fucking. Why? Where's the 5 come from?
You definitely don't factor on. C.
Oh, it's just
I
really close.
think.
You definitely do.
Okay.
Yeah.
Factor.
We are not-
2x.
We're not done with B yet. People are still working on B.
Well,
Factor one of them?
We're not there yet. We're working on B. If you are stuck with C, just chill out for a minute.
No, I don't think you understand. Factoring, I looked at the.
I don't want to hear complaining. Did you get it? Yeah. Yeah, so a little bit off, but okay, let's look at C. To begin C, same way as we began the other ones, we don't want to move the log over because there's a number there. So we combine 2 logs with addition into 1 log with multiplication. Now that I have a single log, and that's really all I have on the left, log of base 2, I do the inverse, exponent base 2. That undoes itself, which leaves me with 2x times x minus 3. Maybe you've already simplified that. I did it at the end. 2 to the third is 8. Then I went ahead and simplified this multiplication. 2x squared minus 6x. If I have an x squared and an x, that is a quadratic. I can't just subtract 6x, divide by 2 squared root. That doesn't work if I have an x squared and an x. What do I have to do? I have to factor. So I have to get everything to one side. If it doesn't factor, you'd have to use a different method, complete the square, quadratic formula, square roots. This one looks like it could be factorable. So you move everything to one side. Notice there's a GCF of 2, which is actually going to make your problem a lot easier. Because I don't want to factor when your A term is 2 and your C term is 8. There's a lot of combinations. But when I factor out a 2, this is an easy factoring problem. I don't try to say easy very often, but this is an easy factoring problem. Things that multiply to x squared are x and x. There are only 2 things that multiply to 4, a 1 and a 4, or a 2 and a 2. We, of course, are going to pick a 1 and a 4, because that can get me a -3 if the 4 is negative. That's factoring? Then I solve. I set each factor equal to 0. If I set this equal to 0, I get 4. Set this equal to 0, I get -1. Set this equal to 0, I get, well, there's no x's there. That doesn't lead to a solution. So I don't get anything there. Doesn't lead me to a solution. Those are my answers. And I have to check both of them. Do we have any questions on any of these steps?
For that factoring thing, could you use a quadratic formula?
You could, yes.
Okay, what is that? Because I forgot.
Negative b plus or minus square root of b squared minus 4ac all over 2a.
Okay.
Do you not like the frog? I don't like
All right, you got about 30 seconds to check it.
I also want to hear the day we learned that, so I knew from that. I'm sorry.
Yeah, do I have food volume?
I'm just kidding.
Have we checked our answers?
Yes.
I'm losing my patience.
Here.
Raise your hand if you plugged in 4 and it worked. Raise your hand if you plugged in -1 and it worked. It didn't work. Who's plugged in -1? Did it work? No. Did it work? No, it does not work. So you would have to show that you got it and cross it out. I don't require you to write the phrase extraneous solution, but that's what it is called. Any questions on why it's extraneous, why it doesn't work? All right, go to the next page. At the top, it says some logarithmic equations cannot be solved symbolically or what we call algebraically using the previous methods, using what we learned today. A graphing calculator could be used though. So take a look at the question that's done for you. Notice you have a log. The inverse of log is an exponent. So this is log base 10. So I have an exponent of base 10 that cancels. But see here, I still have a variable in the exponent. What's the inverse of exponents? Well, see how they kind of just keep like not working together. This cannot be solved using the methods that we've learned using inverse operations. So what you can do is something we've done before. Plug this into y1, plug this into y2. Second, calculate the intersection. We don't have to do anything for this. Let's look at the one that we are supposed to do. I have a log. the log here has a base of 10. So my exponent would be base of 10. Do you see a problem with doing this? No problem here. Problem here, because that and that aren't going to cancel. If I divide by x first, then I have 10 to the 3 over x, which is still an exponent. I would do the inverse. I would get log. I would never really get it to work out. So this is not a problem I would give you and just say solve with the calculator. I'd probably give you a hint and say use a calculator to solve. So grab your calculator. You might want to clear your calculator because it might have a window of like 24,000. To clear your calculator, second plus 712. If you're borrowing mine, they've already been cleared. Plug this into y1, plug this into y2. We are going to skip B. If you finish A, we'll go to C next.
Do we only find the solution for, like, do we only do the x?
1 second. So did you already hit the graph part?
Yeah, and then I found like the intersection.
Yeah, so the x part will give you the intersection. It'll just tell you what height, which happens to be 3.
Okay.
So if you guys forget to calculate, you hit second, and calculate is up here by trace. You're calculating the intersection. Put your cursor about at the intersection for the first curve, second curve, intersection. You can round to hundredths, tenths, whatever it says. 4.56 maybe. We didn't have time for C. I was hoping to get to C. C touches twice, which is not a problem. If you get a graph like this and you get 2 intersections, do second calculate for this point, get an answer, hit second calculate, move your cursor to that point. There you go.